Assalamualaikum warahmatullahi wabarakatuh. My name is Saifullah bin Muhammad and my partner is Muhammad Yusuf Arianto and Siva Susini, and we are from group 15. Okay, in this video I will be explain for lab 4, which is magnet and electromagnet. Okay. The objective in this lab is to discover the magnetic field and to explore the electromagnet interaction between the compass and bar magnet. Okay, for this procedure we need to create our own procedure. Okay, for the step 1 we need to click on link below, which is this link. Okay, and then after that for the step 2, and when the simulation turn on the desktop, we press the button play on the video clip to begin the simulation. Okay, for the step 3 is click on the right box to show the inside magnet, field, compass, and picture meter, and this is the button for the dash for magnet field, compass, and picture, and we can click in this button. Okay. For the step 4 is move the compass around the magnet to analyze the direction of the compass needle. For this figure 3, it shows the direction in the north. Okay, and for the figure 4, show the compass direction in the south. Okay. For the step 5 is same as the step 4 and step 3 to step 4. For the figure 5 show the DC electromagnet, and figure 6 show the AC electromagnet. Okay. For the step C is follow the procedure, see on the left sheet and observe the data. For the step 7, record the data and explain for data of the experiment. Okay. For the question, predict the direction of the magnet field for different location around a bar magnet and electromagnet. Okay. On the north arrow, the compass needed attract to south pole, while the south arrow of the compass is attract to the north pole. For the magnet field for electromagnet depend on the terminal based on the charge flow. For the question 2 is compare and contrast bar magnet and electromagnet. Okay. The difference between bar magnet and electromagnet is the bar magnet has a permanent magnetic while the electromagnet has temporary magnetic field. The number of the loop and voltage or current flow in the magnetic field of electromagnet can be adjusted. Okay, that's all from me, and my partner will be asking for the next step. Thank you.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good day. My name is Muhammad Yusuf Herianto bin Masrupi and my metric number is B0819102022 and I am from class BZ1/2, group 15. So this is lab 4, magnet and electromagnet. So for this lab, I want to present about the number 2 of compare and construct bar, magnet and electromagnet. So this is the PhD simulation. So this is the bar magnet and this is the electromagnet. Okay, question number 2. Compare and contrast bar magnet and electromagnet. So the difference between bar magnet and electromagnet is the bar magnet has a permanent magnetic field while the electromagnet has temporary magnetic field. The number of loops and voltage or current flow in the magnetic field of electromagnet can be adjusted. So this is the bar magnet. As you can see here, this is the magnet. So this is the compass. As we can see here, so this is the north and this is the south. So the direction of compass north attract to the south. So we pass here and then the south area attract to the north. And then this is the electromagnet. So the compass is attract into the coil, which is the positive area attract into the negative, and then the negative charge will attract into the positive. And then for discussion, based on your observation, explain how does the electromagnet works. Okay, the electromagnet are a different from permanent magnets. Electromagnets are made of coil of wire with electricity passing through them. Moving charge create magnetic field. So when the coil of wire in an electromagnet have an electric current passing through them, the coil behave like a magnet. When the electricity stop flowing, the coil don't act like a magnet anymore. Okay, electromagnets are used in a lot of electronic device when magnetic force are only needed for short period of time. So that's all from me. Thank you.
Greetings to Sir, I'm Sivaswashni Uruganathan. My matrix number is P0855 and I'll be explaining about the lab form about the question number 3, which is identify the characteristics of electromagnets that are variable and what effects each variable has on magnetic field strengths and direction. For the number 1 is the number of loops. The more the loops we add, the stronger the field will become. Number 2 is the wire size. So using different types of metal wire will also affect the field strength because every metal has a different inherent resistance to the current. Number 3 is the battery current. When we increase the current, the magnet wire will get hotter and probably fry the delicate electric insulation without which the magnet can't work. Number 4 is the metal core. So steel cores make weaker fields. Neodymium cores make the strongest fields. Sliding the core partially out of the coil will weaken the field because less of the metal is within it. Then, moving on for the part of results and discussion. Okay, so the number 3 is explain the comparison between the Biot-Savart law and Ampere law in words and mathematical equation. So I'll be starting with the Ampere law. So this is the Ampere's law equation. So this equation is valid only when the flux of electric field through the loop is constant in time. Otherwise, its rate of change, which is the displacement current, has to be added to the normal current on its right hand side. This is actually Maxwell realized this. Moving on to the Biot-Savart law. So this is obviously the equation that which I have typed over here. So although originally formulated for statistic situations as well, it's more general for it's valid even if the electric flux changes in time. Provided the electric field is given by the gradient of potential, this happens for example when capacitor connected to battery with self-inductance get charged. A magnetic field around the capacitor does not obey Ampere's law, but it is given as the above Biot-Savart's law. So that's all from me. Thank you, and I'll be passing to my next groupmate. Thank you, sir.